Hello friends, you are watching This is Awesome Videos, and today we are going to solve some past year JEE problems. Okay, so today we are going to solve some AEEE 2006 problems. So let's get started. The first one, 0 to pi x of f of sin x dx is equals to. Now this is a very basic formula. We all know that integration from a to b f of x dx is equal to integration of a to b plus a minus x dx, that means upper plus lower minus x. So at the place of x I'm just going to put pi plus 0 minus x. So let's do that. So I just put I is equal to 0 to pi x of x into f of sin x dx. Now at the place of x I am putting pi plus 0 minus x, that is pi minus x. Here also pi minus x, but sign of pi minus x, that means in the second quadrant, in second quadrant sign is positive, so it left unchanged, it left remain unchanged. So pi minus x f of sin x dx. Now multiply f of sin x dx in this both the terms. So we have pi as a constant, 0 to pi f of sin x dx minus integration of 0 to pi x f of sin x dx, that is I. So this I goes here, so it becomes 2i. 2i is equal to pi integration 0 to pi f of sin x dx. Now I is equal to pi by 2, 0 to pi f of sin x dx. Now we can apply that rule one more time. So just apply this one more time. Okay. Now also sin x here, f of sin x dx, that means you can also write it down. Here it is 1 by 2. This is you can say like this, you can write it down as pi 0 to pi by 2 f of sin x dx. Okay, so because sin x is a function of sin x, and now we can apply that rule one more time. Okay, and if we apply that rule one more time, then what happens? Here it becomes pi by 2 plus 0 minus x. So sine of pi by 2 minus 0 minus x, that means cos x. Sine of pi by 2 minus x is cos x. So we have pi 0 to pi by 2 cos x dx. So answer option number 4 is my right option. Okay, answer option number 4 is my right option. That is pi 0 to pi by 2 f of cos x dx. Okay, this is also one of the good sum. We are going to apply that formula 2 times here. Okay, and here always see that integration of 0 to n a can be written as n 0 to a. This here n is 1 by 2, so this 1 by 2 can goes up in the upper limit, and if the upper limit consists any constant, then it can come to in the multiplication. So this is come by this particular formula. One more integration sum. This is from definite integration, that one is from the indefinite, this is also from the definite integration. Okay, let's see this. Integration of minus 3 pi by 2 to minus pi by 2 x plus pi whole cube plus cos square x plus 3 pi dx. Now this is a pretty good sum, very good sum. Now what we do, we just take x plus pi is equal to t. X plus pi is equal to t. Here also x plus pi is equal to t. That means dx is equal to dt. So we have t cube plus cos square of t plus 2 pi, and we all know that t plus 2 pi, that means in the first quadrant, cos square of t plus 2 pi, that means cos square t. Let's do that. What I do, here is my equation. I is equal to minus 3 pi by 2 to minus pi by 2 x of pi whole cube plus cos square of x plus 3 pi dx. Now I just take x plus pi is equal to t. So we have dx is equal to dt. So in the place of dx, I just put it down dt. In the x plus pi, we have t cube. I already told that x plus pi is equal to t. So we have t plus 2 pi. T plus 2 pi, that means cos square remain unchanged because in the first quadrant. So we have cos square t here. Now we all know that from minus a to a, that means we can apply the odd and even function rule here. So t cube is an odd function, so its integration becomes 0, and cos square t is an even function. So we just have to find out the integration of cos square t particularly. So here minus pi by 2 pi by 2, it's written as 2 into 0 to pi by 2 cos square t dt. This is very basic thing, so we all know that. Okay, so it's 0 to pi by 2 cos square t. Cos square t can be written as 1 plus cos 2t by 2. Okay, 2 gets cancelled out, so we left with 1 plus cos 2t. And what's integration of this? Its integration is t plus cos of t plus cos of sorry, integration of cos, that means sine 2t by 2. But if we put pi by 2 and 0 in the sine, we have nothing. Okay, answer is 0. And so here it becomes pi by 2 plus 0, that means pi by 2. Now please note this point: if we take an assumption of any value x plus pi is equal to t here, then we must have to change the limits also. Here if we put x is equal to minus 3 pi by 2 here, so it becomes minus pi by 2, and if we put minus pi by 2 here, it becomes pi by 2. So as we take an assumption, we have to change the limit also. Okay, so this is also a good sum, not containing a very big or large formula, but the basic things are applied. One more. This is from the sequence series. It's also a very good sum. Let a1, a2, a3 be the terms of AP. If a1 plus a2 plus up to ap upon a1 plus a2 up to aq is equal to p square by q square, where p not equal to q, then a6 by a21 equals to. Very good subsequence and series. Those students who don't know the formula, please go to the topic lecture and watch the sequence and series video lectures. Okay, in that video particularly I mention all the formulas of sequence and series, because in this chapter sequence and series the formula is most important thing. Okay, so here we know that a1 plus a2 plus ap, summation of ap, and that formula is n by 2 2a plus n minus 1 into d. So I just do that. We have here we have a1 plus a2 up to ap, that means we have p terms. Okay, so its formula is p by 2, that means n by 2, 2 first term is a1 plus p minus 1 into d, d is the common difference, upon same for the denominator, q by 2 2a1 plus q minus 1 into d. This 2 gets cancelled out, this 2 and this 2 gets cancelled out, this p cancel out from this p square here, so we have only p here, and similarly this q will cancel out from this q square, so we are left only q here. So p by q is remained, and we have 2a1 plus p minus 1 into d, 2a1 plus q minus 1 into d. Now 2 gets common out and cancelled, so we have a1 plus p minus 1 by 2 into d, a1 plus q minus 1 by 2 into d. Now what we have to find out? We have to find out the value of a6 upon a21. Now tell me, what is a6? This is also I teach in the video lectures that a6 can be for in a AP. A6 is written as A6 can be written as a plus 5d. We all know that. And similarly, a plus 5d, and a21 can be written as a plus 20d. So here we have the first term. We have the first term here. See, a1 is the first term, and p minus 1 by 2 can be what we have 6, so it becomes 5d here. So p minus 1 by 2 must be what p minus 1 by 2 is 5, that means p minus 1 is 10, that means p is equal to 11. For 21 this becomes 21, so q minus 1 by 2 is 21, so q minus 1 is equal to 20. Okay, q minus 1 by 2, so it becomes 20 here, because a1 plus 20, so it becomes q minus 1 is equal to 40, so and q becomes 41. So just put these two values here and here. So here we have a plus 5d, that means f6. Here we have a1 plus 20, that means a21, and here we have 11 by 41. So this is my answer, 11 by 41. Answer option number 4 is my right option. Very good question. Okay, AIEEE 2006. And the last one, the set of points where f of x is equal to x upon 1 plus mod x is differentiable. Okay, now we have to find out the points where this function is differentiable. Now here the standard we can say is box x. For box x we know the basics. If x is greater than 0, then box x is, two things can be possible: either it is greater than 0, or maybe it is less than 0. If it is greater than 0, then box x is equal to x, and if it is less than 0, then box x is equal to minus x. So I just do this separately. here f of x is equal to x upon 1 minus x. If x is less than 0, so box is equal to minus x, so function becomes x upon 1 minus x. And in the denominator we have x plus 1, sorry, and if x greater than or equal to 0, then we have x plus 1 by x, because box x becomes mod x becomes x. Okay, so we have two functions for x less than 0. If we take the differentiation of this, then we all know the basic. This is the differentiation can be done by the division rule. I'm not going to that. If you apply that rule, the answer is 1 upon 1 minus x square by 2 if x less than 0, and for x greater than or equal to 0, it becomes 1 upon 1 plus x square. Now see here, this never becomes infinite, so f dash of x exists at everywhere, each and everywhere. See here, if this for x greater than 0, then at the point 1 it is non-differentiable, but it is for less than 0, then this thing is never going to be undefined, and here it is always plus and x greater than 0, so it's not an issue for that. So f dash of x is exist at anywhere. That means answer option number 3 is right option, that is minus infinite to infinite. That means the real value set r, minus infinite to infinite is the r only. Okay, so this is the sum from AIEEE 2006. Very good sum. Since from the last almost 1 week we are solving the past year AIEEE problems, this is going to help you a lot. Please watching, and if you have any query, click the pic of that photo, click the photo of that sum and post in the comment. I'm going to solve that sum and post a video on that. Okay, so thank you for watching this video, and if you like this video, don't forget to share it and hit that subscribe button.